management and making sure the project manager has the authority over the multiple disciplines that are involved in the project, not just the responsibility but the authority too. And then the project managers should report up to a program management office that has very consistent guidelines across all the projects in the organization. And the bottom line we learned here was you really need to build an A-team of your very best project and technical members, because there will be challenges to collectively solve, and many of these may be in the field. You need a corporate steering committee, because once a strategy for the organization is put together, you want to make sure that that strategy is implemented. So if anyone has an idea for a smart grid project, it has to be vetted, right? It has to be considered with respect to the company's overall strategy. Is it aligned with a strategy? Is it different? Is this something we should do? That type of thing. And then what you find is many of the utilities will have alliances with certain key suppliers. The supplier will provide on-site management and technical support, but also the supplier knows the customer's needs. As we develop new products, we'll make sure that those needs are incorporated in our new developments. So it's a win-win for everybody. And then, one of the things that's new for us is the residential customer is a new residential commercial customer is a new stakeholder. As we get into home energy management, we saw about empowering customers to manage their energy use without compromising their lifestyle. You can't put a successful program together at the customer level unless you've engaged customers, you understand their characteristics, their price points, and realize that not all customers are the same. We segment customers based on characteristics and price points, and we've done this. We did this at GE. Came up with 4 or 5 different segments. We also did this in an industry organization that I'm involved with called the Smart Grid Consumer Collaborative, SGCC. Their website is smartgridcc.org, and there's some really good segmentation results that we include on the website. And then the last thing is use cases. Everything that we do, we should put a use case together that describes the scenario, defines the benefits, who's involved or the actors, functional requirements, and the business rules and assumptions. And you can find example use cases on many utilities' websites that they've implemented themselves and they provide for others. So my last slide here is an article that I did for the IEEE Potentials magazine, which is for students, November, December of 2011. And this is not what I look like today. This is from my office at work in 1975 with Bechtel Corporation in downtown San Francisco. And I grew up in the Chicago area, went to school at Purdue, as Aaron said. I'd never been further west than the state of Illinois all my life, and I accepted my first job after grad school at Purdue in downtown San Francisco. So I drove 4 days cross country, didn't know anybody there, looked for an apartment, and started working. And after I worked there 4.5 years, and here's the lessons I learned in my first job. Don't let a disappointing work situation affect your attitude in work, because it will change. I worked for a guy who, I did all the technical studies for a very, I would say the world's largest copper refinery that we were designing and developing. And my boss would have me explain my work to him in extreme detail. And he would take everything I did and he would be the one to present it to the customer and take all the credit and not give me any credit. And that really bothered me. This guy couldn't have done the work himself. And but I didn't let it bother me. I kept working hard, kept a positive attitude, and in a short period of time, he changed projects, wasn't working on a project anymore. And then the photo you can see over my left shoulder is the chief electrical for the project, Chuck. Chuck came to me and said, John, I know you've been doing all the work on the project. Now you'll be the one to present it to the customer. So, you know, don't let things get you down. Persist. Nothing is permanent in anything that we do, but don't let it bother you. Just keep working hard, and it will change. Also, no one is indispensable. Continue to do more than expected. Provide value to the company. Don't be more than accurate with what you do. Like I was calculating short circuit currents and I came up with 23,214.2 amps. And my boss said, John, what I want is precision without accuracy, which I'll never forget. Be precise, but don't overdo it, you know. Also, we get focused on the technical side of stuff and forget how important the business side of the technology is. So that's why I got while I was working during the day, I went to school at night at Berkeley to get an MBA in finance and have a much better appreciation for the business, the finance side. But also, in 1997, a market researcher surveyed 100 utilities in North America and said, what's the leading obstacle on why you haven't implemented substation automation to a greater extent in your organization? And the leading obstacle was the inability to put the business case together to get the approval from the leadership of the organization. So it was a good wake-up call for us that we need to teach not only technology, but the business side of the technology too. Also, I said get a professional engineer license as soon as you can, once you have the required work experience, assuming you've passed the fundamentals of engineering exam, which hopefully you did while you were at the university or shortly thereafter. Serve as a mentor for young engineers. You learn a lot yourself. And lastly, and most important, get involved in outside activities. I've learned so much and had so many leadership opportunities with IEEE and IEEE PES. Offer to give talks, teach courses, develop standards. Just do as much as you can because the opportunities are there with IEEE. It's an open organization. It's really up to you and your initiative to take advantage of it. So on that, I'll end. I want to thank everyone and open it up now. We've got about 11, 12 minutes left for any questions that came in. So Aaron, I'll turn it back over to you with respect to questions.
Okay, thanks, John. Thanks again, very interesting presentation. We're getting a lot of good feedback, and I'll tell you right now before I forget, but I think I got a few people stating that they really enjoyed the last slide and the lessons learned that you're presenting, and also the positivity. So a lot of good feedback.
I'll keep that slide up then. And
yeah.
if people want to know more detail, they can go to that that issue of the magazine, Aaron. Here it is, November, December 2011 issue, and read the full article.
Okay.
Or Aaron, it's up to you. I can email you the PDF if you want, and you could send it out to everybody. It's up to you.
Yeah, please do. Send me that, and I'll send it out.
Okay.
And related to that, would you be okay if I shared a PDF version of these slides with the attendees?
No, as long as it's in PDF, that would be fine.
Okay. All right. So I'll send both of those out today or tomorrow.
Okay.
Okay. So I've got a number of good questions. I think you'll probably be able to hit them all, more or less. But kind of related to this smart grid technology or the modernization of the grid and dealing with integration of distributed resources. A good example is rooftop solar. You had some discussion on that. And there are a number of questions talking about how this technology can help facilitate better integration of these technologies. And I had two specific ideas brought out. One, dealing with kind of the high penetration of renewables that you kind of touched upon here. And secondly, providing better operation. Like, for example, right now, at least in the U.S., if the grid goes down, distributed PV has to separate from the grid and not produce power. I think it would be nice to be able to form community microgrids and continue to provide power from these distributed resources if possible. So I guess to kind of come full circle, the question is, how can some of this technology kind of lead to some of those higher level goals?
Yeah, so let me do, I want to make sure we get through all the questions, so I'm going to be as brief as I can with responses. But I would say, you know, the new technology in that article I wrote talks about 3 areas of new technology. To me, with the first question is low voltage network dynamic grid edge controllers is new technology that we need to continuously compensate for both voltage and reactive power on a continuous basis, but at the low voltage network level, which is where the volatility is introduced into the grid, where the PV panels are. Because historically we've used capacitor banks at the voltage level higher at 13.8 kV to do the compensation. Not as efficient. So I like us moving further downstream in the network, having dynamic grid edge controllers, and it's a cultural change for us, but I think it's much more efficient. And then let's see, I'm going to think of the second part of this. The IEEE standard for the integration of renewables into the grid is IEEE 1547, and we amended that the last half of last year. So you can Google 1547A, small a, and you'll find 2 major changes with that amendment. One is we do not have to decouple all the distributed generation from the grid when a disturbance occurs anymore. There's more flexibility for utilities. And the second part of that is we can now use smart inverters to do voltage and reactive power compensation, which we weren't allowed to do before. So, and that's why I say with smart inverters, let's take a look at the inverter, add more intelligence to it, give us more control capability as particularly a VAR resource, because the standard now allows us, the amended standard allows us to use that as a VAR source. And the higher penetration of renewables, the more inverters we have, and the more VAR capability that we have.
Okay, thanks, John.
Okay.
And I also had a couple questions in regards to the communication infrastructure. You spent a lot of time talking about specific standards and how they fit into the smart grid. But I was curious on the longer range communication infrastructure, say from substations to utilities to maybe even system operators at the high level. Physically, what does that look like? What technology is being used as the communication medium, and is it commercial or private?
Good question. The communications infrastructure for any utility is a hybrid mix of a lot of different technologies. So at the top end, you need something that's very reliable, has a tremendous throughput or bandwidth, and something like fiber optics with SONET, or something like microwave is used. So it could be wired or wireless. Then as we go further down into the system, we might get into licensed UHF wireless radio. Licensed because we're in an urban area and we want to be the only approved user at that frequency, so we don't want interference. But as we get further down into the service area and towards that last substation, we can go unlicensed spread spectrum wireless communications, because we're more in a rural area. The chance of interference is very low because there's no other users in the area. And we can get unlicensed, which is cheaper. Okay, we don't have the licensing step. So it's a mix of wired and wireless. Now, the two key decision points are wired versus wireless. You know, do we go wired or do we go wireless? Because you have choices in each. And the second decision point is do I own the communications infrastructure, or am I leasing it from a third party, which is the same as, you know, private versus public. The tendency in the past was the utility would prefer private and actually pay a premium to own the infrastructure because they controlled it. They controlled the cost, and they controlled the troubleshooting if there was a problem. Now, as we look to the future, we see more openness to using public carriers where there's a like a monthly cost, and also there's a service level agreement, an SLA, with the third party to say if there is a problem, we expect you to respond within so much time. There's an agreement to that effect. So those are the decision points. And in a course I teach, I have about an hour and a half of material on all the different communication technologies, wired and wireless, and you step through them in terms of advantages, disadvantages. But at a very high level, the three things with communications, Aaron, that we look at is supporting the response requirements of the application in seconds, the bandwidth requirements in terms of bits per second, and third is how much latency can we tolerate or delay in seconds. Okay?
Okay.
So those are the decision points.
No, one of the first things you mentioned was reliability, which is obviously of utmost importance. But how is the contingency of loss of communication handled or looking to be handled in a lot of these applications? Yeah,
and this gets back to what I said about resiliency and reliability, we have to look at the criticality of the system that we're architecting and how much redundancy we can afford to pay for. For instance, in the control center, the energy management system, which is the SCADA system that controls the generation transmission part of the grid, or the DMS controls the distribution part, is always fully redundant. So we have a duplicate system. We have two that are connected together with automatic failover, a watchdog and automatic failover. When data comes from the field, it goes into databases in both systems. And so one is online, one is in hot standby, and if any problems detected with the online system, we automatically fail over very, very quickly to the hot standby. That becomes the new online system, and it takes over. So things that we deem as critical, then we can justify additional expense, in making it more reliable. So we have to really look at what is it that we're architecting, what's its criticality to the organization, and then look at the business case of how much money we can spend, with respect to different levels of redundancy.
We also had a number of questions related to security. I think, cyber side, and also really we're talking about an integrated cyber physical system here. So I think you need to look at security at a holistic perspective. But in your opinion, John, is the current technology there to properly secure this system, or are there concerns and work that needs to be done there?
Well, cybersecurity is something that everything that we develop, any technology, it's at the forefront of the development. And the primary thing with cybersecurity is you have to include cybersecurity considerations from the very beginning of the development. You can't be halfway through a development and say, oh, I'm going to do cybersecurity now. It just doesn't work. So it's at the forefront of the development. Secondly is when you're architecting a system, look at different levels of security that you need. For instance, two-factor authentication, three-factor authentication, encryption, digital certificates, passwords, different approaches, and decide what level you need and then where that functionality should be located. Because when you're in the real world, you've got to take into account price performance issues with technology. So, I may, if I include functionality at the device level, I buy more devices than I do the gateway that the device reports to. And if I can get the same end result of coverage by putting that functionality at the gateway level, it'll be less cost to the customer because there's less gateways bought than there is devices. So We have to look at price trade-offs, performance trade-offs, architectural trade-offs, but the bottom line is everything that we do today involves cybersecurity. And I would say from a vulnerability point of view, everyone is doing the best job they can, with respect to implementing cybersecurity from a taking into account the business case of the criticality of what we're doing versus how much money can be spent versus the level of security that's desired.
Okay, well put. I had a couple questions in regards to standards as well. You listed quite a few standards related to the evolving smart grid or grid modernization, and I had two questions in particular. One, some viewers were interested if there are any gaps that you've identified that still need to be addressed in those standards.
There are gaps, and that's why the SGIP, the work we're doing at SGIP, is so important, because the light green boxes here in the middle, the priority action plans that are currently being worked on, are gaps. Those are gaps we identified. And so the groups on the left, the dark blue groups, are more visionary groups in different areas of the grid, like vehicle to grid, home to grid, building to grid, industry to grid, T&D, distributed renewables, generation and storage. They identify gaps. Where's technology going? How quickly is it moving? How are we integrating it into solutions? What are the solutions that customers are looking for? How are these going to interoperate? And do we have the standards that are needed? And so these, 12 boxes, light green boxes in the middle, is work being done to address gaps. So we're always looking and identifying gaps. And when we identify it, we mobilize a team of subject matter experts with expertise in that area. They put a proposal together, and once it's approved, then it's basically a skunk works operation like Microsoft or Google would do, and let this group of subject matter experts take off, and then we emphasize the acceleration of that work to get it done in 6 months, a year and a half, which is much faster than the typical standards process in IEEE and IEC, which is 5 to 6 years.
All right, also a follow-on related to that, the classical methodology of protection coordination, is that sufficient in this evolving grid, or is there work being done to improve and try to standardize how protection coordination will be done in the future?
Yeah, that's a good question, because there's work being done in several areas. At the transmission level, it's a couple things. One would be remedial action schemes, or we call wide area protection and control, where we have protection devices over a wide geographic area interconnected with high-speed communications and logic that's looking at constantly looking at possible trigger points or faults or disturbance conditions that can occur. And if one's detected, it immediately implements a set of logic. And the objective is to isolate that and not let it cascade into a worse situation. So this is new types of protection schemes over a wide geographic area. Second, still on a transmission level, would be synchrophasers. And incorporating synchrophaser information, which we're getting many samples per second, which typically with SCADA data we would get a sample every 2 seconds. So it's making use of this new information, which is at a much faster sampling rate, and it enhances then our ability to protect the system, particularly from like a transient stability, a transient situation where we need to have more samples more frequently. And we're just at the forefront here of utilizing this new synchrophaser information in all the ways that we can. And then third would be on the distribution level. When we do fault detection, isolation, restoration, we may be moving segments of load on a feeder from one substation to another. And we have, it's called an application in Smart Grid called adaptive relaying. And that's having predefined multiple time current protection settings. And so we know that if this fault occurs, we close this normally open tie switch on a feeder, we move these blocks of load to this other substation. The feeder breaker on that feeder that now has the additional load, we know it's going to need a new set of time current characteristics, but we've already studied it, it's already pre-stored, and we send like an analog set point command to that device and say, hey, begin using this other set of characteristics, you know, and it automatically changes. So part of a distribution automation application very much could be adaptive relaying as part of it. So there's a number of, that's just 3 just off the top of my head, but there's a number of other things we're doing new, you know, with respect to protection.